Look closely at the trajectory of an average tech career today, and you will clearly find an anomaly. An immense concentration of capital is shifting away from traditional software development and directly into a very specific set of hands. Take San Francisco in 2019. A standard software developer, let's call him Jake, was earning a baseline salary of $95,000 a year. His career path was steady, predictable, and firmly capped. In 2021, rather than following a standard academic route, he spent his weekends studying machine learning independently through online video resources. He added a single, highly specialized layer to his existing coding background. By 2026, working in an artificial intelligence research lab, his base pay reached $260,000. Factoring in equity, his total compensation cleared $500,000 annually. The financial shift was immediate. This pattern of compensation is a direct result of market scarcity. As companies compete for a limited pool of talent that can build these systems, industry projections suggest base salaries for these specific roles will consistently exceed the $200,000 threshold by 2030. Right now, typing instructions into consumer-facing tools feels like a professional advantage. Yet the ability to merely use these programs is rapidly being automated out of existence. We have seen this market behavior before. When mobile phones moved from specialized items to basic utilities, the premium on knowing how to operate them vanished. The market discarded the users and heavily compensated the developers who built the infrastructure. This chart illustrates the current demand cycle. Applied machine learning job postings jumped 163%. Capital is aggressively flowing away from those who treat technology as a novelty and straight to the builders who translate it into measurable business results. The foundational role capturing this capital is the machine learning engineer. Industry data ranks this as the fastest growing job title in America, with year-over-year posting growth reaching 143%. Consider Maria, a traditional back-end developer in Texas. By applying a layer of machine learning to her existing codebase over 18 months, she transitioned to a senior AI engineer. Her compensation more than doubled in that window. Beyond baseline engineering, heavy investment is pouring into giving machines spatial awareness. Computer vision engineers write the algorithms that allow systems to process and interpret visual data from cameras. This capability is the core functional requirement for autonomous transportation. Self-driving vehicles rely entirely on these engineers to translate pixel data from physical sensors into split-second navigational decisions on real streets. Inside heavy industry, these same visual models scan production lines, analyzing microscopic defects on factory floors with a speed and accuracy human inspectors physically cannot match. The most aggressive capital deployment is happening in medicine. The healthcare artificial intelligence market is scaling toward $110 billion by 2030, driven by the desperate need for engineers who can train models to detect anomalies in medical imaging, like X-rays. In parallel, natural language processing engineers are structuring the $67.9 billion language market, fine-tuning the massive data models that power commercial voice assistants and automated writing tools. The immense salaries attached to these specific roles exist for one precise reason. These engineers act as the physical bridge between raw, abstract code and tangible, high-value utility. At the absolute top of the technical hierarchy is the AI research scientist. Inside elite cutting-edge labs, senior researchers command base salaries between $250,000 and $320,000, with total packages frequently scaling past $1 million. Historically, these roles were locked behind rigorous PhD programs. Today, those institutional barriers are collapsing. Hiring managers are increasingly prioritizing independent portfolios and self-published papers with high citation metrics over traditional academic degrees. For those who prefer strategy over complex coding, companies are heavily recruiting applied AI product managers. They need leaders who understand the underlying technology well enough to direct engineering teams and execute commercial product launches. This diagram illustrates the most accessible opportunity in the market. When deep industry knowledge intersects with applied machine learning, it creates a rare profile that commands a 30 to 50% salary premium over tech generalists. By stacking technical skills on top of an existing career background, a specialized nurse, a corporate accountant, or a supply chain manager becomes uniquely valuable. Corporations will pay heavily for an insider who understands their specific logistical bottlenecks and possesses the technical capability to solve them from the inside. The highest professional leverage requires both the technical knowledge of how a model operates and the practical knowledge of exactly where to aim it. The initial experimental phase of this technology is ending. Basic competency is rapidly losing its value, and the baseline requirements to secure these positions are rising sharply. The job market is preparing for massive churn. The future wealth generated in this sector is reserved exclusively for the professionals who can integrate, secure, and govern these complex data structures across different domains. We are watching a historical pattern repeat itself. The frantic allocation of capital happening right now mirrors the economic gold rushes of previous market booms, where fortunes were built by those supplying the infrastructure. Taking advantage of this window requires a strict, focused sequence. It starts with building a robust foundation in Python and immediately narrowing focus into a highly specialized niche like computer vision or language processing. From there, the objective is to build tangible proof of work, deploy a functional project, and actively hybridize that technical system with the domain knowledge from your current profession. This is a concentrated, intensive process of deliberate learning that typically requires 12 to 18 months of disciplined effort to bridge the initial skill gap. It is a significant time investment, but it offers a pace of advancement that outstrips traditional senior-level promotion cycles. The economic transition is happening right now, in real time, and the immense capital generated by this shift will flow directly to the builders. If you want a dedicated step-by-step breakdown of how to move from zero to an AI engineer in 12 months, leave a comment with the word roadmap, and we will cover that transition in our next video.